So scripting is what you can do in order to combine certain commands into a script that you can execute in the same way that you can execute simple commands. So we've seen a lot of commands today, maybe like 10, 15 different ones with the cd, change directory, pwd, ls, we've seen cat, less, lots of different things. And all of these, if I go into my terminal here, all of these are available if I just type in the name. So here, notice I'm sitting in my home folder. If I just type in ls, this is essentially a script that I am executing. When I hit enter now, it is running some code. And this you can actually, if you want to, this you can do on your own time, go look at the code that is running, because ls is basically just a file with some code inside it that runs when you type ls into your terminal. But we can also create new files like this and new scripts that we can run as a whole standalone thing. If we have some, for example, repetitive task that we want to do over and over, such as, for example, listing the files in a directory. This is something that is necessary to do over and over again. That is why ls exists as a standalone program. So I will once again reuse the same files and folder that I downloaded for the finding things session. If you want to follow along, type along with me. You can also just do the same as I did before, download this finding things folder and extract it, and then you'll have everything you need. So if you didn't do it before, you can copy this into your terminal and run it, and then it should get you everything you need. Okay, so let's now look at how do we create a script. And I'll mention very briefly this morning, there are different flavors of terminals. The most common one, the most widely used, I think, is called Bash, and this is what is default on all the NRIS machines, and that is what we will use today. And it's what we've used in the terminal all throughout the day so far as well. So we will now go into how to make a script in Bash. So Bash is just essentially just a programming language like any. We will probably in your career as a scientist run into multiple different programming languages. Bash is just one of them. So in the example that we are seeing, let me go. I'm in my home folder. Let me navigate into finding things, the finding things directory. So cd, change directory, we go into finding things. In here, let's do ls, list all the files. And we see in here we have a file called list.sh. Now, if we want to look at the contents of this, we learned before that we can use, for example, cat. This will print the contents of this file to our terminal. So let's do that now. Press enter. And we see this has some commands in it. But what I will actually do is I have this open in my VS Code editor. So I will just show it up here so you can keep track of if we change anything in it. Excuse me. So the contents of this list.sh file is shown up here. Notice this first line with the hashtag exclamation point is called a shebang. I don't think we need to go into this. This is basically just saying to your terminal, which program should I use to interpret what is in this file. But you can read up on this if you want to. So the way that we can run this file now is to say that we can write bash and then the name of the file. So let's do that. Let me make some space here if I can. So inside the finding things folder, let's write bash. This is telling my terminal that whatever I give in as an input here, please run this as a bash script. And we will input list.sh. Now let's press enter and see what happens. So it says all the PDF files in the current folder. This is the current folder. And here it lists all the PDF files. So we can also see this from looking at the file, what the contents of the file are. We see there is this shebang thing that we will not worry about too much today. There is a line here, this green line starting with the hashtag. This is a comment. So this is a bash comment. So this will not execute anything. It's just here so that it's easier for us to read. Then there is an echo command. We've seen echo multiple times already. So the echo command, recall, it just prints whatever you give it to the terminal. So here it says echo and this string, and this is printed here. Then next, we have the pwd command, so print working directory. This tells us where we are, and that is what's happening here. So this is the second line, excuse me, of the output. And then the last line is this ls list command with the wildcard.pdf. So this will list all the PDF files in this current directory. So that's what this bash script that we have in here is doing. Notice that this is different from when we just use ls or cd or cat as a program, because if I just want to use cat or ls or cd, I can just write the name and nothing before. Whereas for this script, I had to write bash first and then the name. So this would be analogous to writing bash cd or bash ls. So sometimes it is convenient to avoid having to do this and just make this file into a file that you can execute directly. Now, in order to do this, we need to change a property of this file. We need to make it executable. If we try, yeah, there's a comment here about if we just try to type list sh, our terminal will be confused because it won't know where to find this this file, even though we are standing in the same directory where this file is located. If I type enter now, our terminal is confused and it says, I don't know where to find this list.sh command. So this is a quirk of the terminal. When you ask the terminal to execute a command or a program, there are a very specific certain places where it looks for these programs or files. And if it can't find it in those targets or those directories, it will just say, sorry, I don't know what to do. This is called a path. I'm not sure if this will be maybe mentioned later on, maybe tomorrow or Thursday. In order to overcome this, the way to tell your terminal that we want to execute this file that is located right here where we are is to, instead of just typing out list.sh, you prepend this with // So this is telling your terminal explicitly, I want to execute the file called list.sh that is located here in the directory which I am currently located. So let's try and hit enter now and see. So notice before it was saying, my terminal, my bash was saying, this command is not found. I don't know where this file is. Now it's saying, actually, I know where the file is. I'm trying to execute it, but I don't have permission to execute this. So this is where we need to change permissions to make this an executable file. But first, let me hide this real quick and use ls list files. So let me see all the files in this directory in the long form. So with the -l, and hit enter now. And now we get back to what I briefly mentioned and asked Buket about earlier today. What are all these things at the start here? What are these? Why are they there? And now we run into this exact issue. So ls.l, so the long form of ls, has a lot of information. So looking at the relevant line here for this list.sh, on the left here, you have a bunch of characters, and they represent, if we scroll down here, we can see all of these permission bits, what they represent. So here it says the very first one is just saying, is this a direct directory or not? The next three, so these three are saying, what kind of permissions do I have? Because I am the user, I own this file. I just downloaded it and it's my file. What can I do with this file? And this is saying I can read from this file, I can open it, I can view the contents. This W says I can write to it, I can change, I can make it a new file, I can change the contents. And the last one here, which is absent, would be if I am allowed to execute this as a function, as a program. And this is missing. So in order to change this, we can use the chmod. Excuse me, there are lots and lots of information here that you can go through if you want about what all of these things mean. But for now, we just want to change the permissions for me, for the user, to be able to make this executable. So let's see if we can do this. We use chmod. It's a new command. It changes permissions for files and directories. +x gives us, so we add the executable flag. So this file will now be able to be executed as a function, as a program. And we give in the name of the file. So chmod +x and then list.sh. So now when I hit enter, it doesn't give any output on the terminal. But if we again use ls.l, we see before, so the output before had read-write permissions, but nothing else. But now we see it actually changed color, so now it's green. And there's an X here, and it actually added executable permissions for everyone. So not just for me, the owner. So now we can go back and we can run the script without prepending the bash. So just run it as a program. So let's do that. Remember, in order to tell the terminal, look in this specific directory, we need the // and then we say list.sh. And hopefully now when I hit enter, let's see, it should work. And it gives us the same output as before when we ran the file with the bash in front. So just very briefly, before we go on. We can also change what this small program that we have created does. So maybe, for example, I want this. I think when it prints all the PDF files in the current folder, I want there to be a colon because that looks nice. Then if we just save this file and execute it again, we will see these changes are made on the fly. So we don't have to change the permissions again after we make changes to it. If you have a file that is executable, even if you make changes to it, you can still execute it as a function, as a program, excuse me. So this was a very, very brief introduction to scripting. We will see more about scripting tomorrow and on Thursday. You will learn both more about scripts and more complicated scripts. And in particular, you will learn to interact with the scheduler for the clusters and how to write what is called job scripts. But for now, I think that concludes all the sessions for today.